Hello, everyone, and welcome to the Future Space. I'm your host, Daniel Fox. Our guest today is Avi Loeb. Avi is the Frank B. Baird Jr. Professor of Science at Harvard University and a best-selling author. He has written 9 books as well as over 1,000 scientific papers. Loeb is the director of the Institute of Theory and Computation within the Harvard Smithsonian Center of Astrophysics and serves as the head of the Galileo Project. He is the longest-serving chair of Harvard's Department of Astronomy and the founding director of Harvard's Black Hole Initiative. He is a former member of the President's Council of Advisors on Science and Technology at the White House and serves as the Science Theory Director for all initiatives of the Breakthrough Prize Foundation. In 2012, Time magazine selected Loeb as one of the 25 most influential people in space. Avi, welcome to the Future Space.
Thanks for having me. We could have saved you time if you refer to me as a farm boy. I'm just a curious farm boy still. I was born on a farm, collected eggs every afternoon, and used to read philosophy books on the hills of the village that I lived in.
So is that where your love for the sky and the space was born?
Not so much the sky. I was not into astrophysics. I didn't like science fiction, but I was connected to nature, much more so than to people. The way my wife phrases it is that I have very poor social skills. But the way I see it is that, humans have a lot of faults. They have wishful thinking. You cannot trust them. I don't care how many likes I have on social media, for example. I have no footprint on social media. But, I really enjoy learning from nature. And the way you learn is by having an idea. It's called a hypothesis or a theoretical model in physics. And then you test it by the guillotine of experiments. That guillotine chops the head of most ideas that we have. But that's why a lot of people prefer not to test their ideas. They surround themselves with like-minded people on social media, and they can believe in whatever they want forever. And I would have expected scientists not to engage in that activity, but that's not the case. For example, I asked my research group at Harvard, just a few months ago, I asked them, what makes a theoretical physicist happy? So there was silence in the room, and then I answered the question myself. Lack of data. Because when you don't have experimental data, you can still maintain your view that your idea is correct. And in fact, if you work on string theory, you can do that for 50 years without the risk of being wrong, because there are no experiments that test the validity of string theory. There are no experiments that would prove it wrong. And so you can keep doing intellectual gymnastics and declare yourself as a very smart person, the way that athletes test themselves by running 100 meters. But it's not about that, actually. Scientific inquiry is supposed to educate us about nature. We want to learn something that describes reality, the reality that we all share. Of course, we can take recreational drugs, or we can put goggles on our head that put us in the metaverse and believe in realities that not all of us share. And we might find them enjoyable. Taking recreational drugs is very enjoyable to some people. But that's not physics is about. It's about the reality that we all share. And it's not always enjoyable, because sometimes it tells you that your ideas are wrong. But that's the beauty of science. And that's what I enjoy doing. And I got it from being born on a farm and falling in love with nature. I have a romantic relationship to nature itself. And the biggest question that stands in my mind right now is, do we have neighbors? That's a simple question. And I'm talking not about neighbors on the street in the city that we live in, but actually neighbors in our cosmic environment near another star. When I look at the sky at night, is there someone else staring at us from out there? And if so, can we learn from those? That's the biggest question in my mind. And I just, you can define life as the time that we spend until we die. Okay, basically what we do until we die. And it's really unfortunate that a lot of the activities that humans engage in are destructive or hateful, and because they reduce that lifespan that we have, rather than doing something more constructive, which is, in my mind, peaceful, not engaging in conflicts and exploring. And the biggest question that we can ask, the thing that is most worthwhile exploring, is space, because that's where most of the real estate is. It's not here on Earth.
Yeah, you and I would definitely have the similar background. I grew up, with my heart and my imagination wandering the forest and nature. In fact, I did sort of wilderness expeditions for 15 years and wrote the book Feel the Wild. And my years of spending 2-3 weeks by myself out there in a remote wilderness was always an exercise of humility, right? You get to face these forces that are bigger than you. And yes, we've achieved so much in managing and engineering the unfairness and randomness of nature, because it kind of doesn't care if it works. It does trials and errors on a scale that is so much bigger than we can comprehend, but ultimately for the purpose of life to moving forward. And the humans have managed to kind of create a certain stability over that, and we can build on it. But ultimately, at the end, these are forces that are so much bigger than us. But it's at the same time, I cannot but think that we're about to give life its biggest gift in billions of years on Earth. We're about to take it beyond. Because why would you grow in complexity to remain on one tiny speck in the grand scale of the universe, right? It wants to continue beyond and beyond. And for the first time, there's one species that is about to take it. So that's...
Yeah, I completely agree with you. Humility is really key. And in fact, we keep getting that message from the universe: stay humble. And we refuse to take it. So we started by saying that we are at the physical center of the universe. That's what Aristotle argued. And then Nicolaus Copernicus came along and suggested that we are not at the physical center of the universe. And I mentioned Nicolaus Copernicus because he was born 550 years ago. And in 2 weeks, there is a celebration of his birth organized by the Polish government in the town where he was born and worked, Toruń, in Poland. And I was invited as the keynote speaker for that celebration. So I will be there in 2 weeks. And they asked me, what would be the title of your keynote speech? And I said, the next Copernican revolution. And I explained that the next revolution would be that we are not at the intellectual center of the universe. So many of my colleagues, if you ask them, they would say, oh yeah, maybe we are alone. In fact, if you ask Elon Musk, he just gave a month ago a sort of a review of 2024 in the context of Starship, and said, I haven't seen any evidence for aliens. And that brings a big responsibility for us, the human species. We need to become a multi-planet species, because maybe there is nobody like us. We are great. And I say, well, that's not the way science is done. You can't just say, the evidence didn't fall into my lap. We invested $10 billion in the Large Hadron Collider to find the Higgs boson. We invested $10 billion in the Webb telescope to find the first galaxies in the universe. We didn't say, oh, I look up and I don't see the first galaxies. I look around and I don't see the Higgs boson, therefore I don't know if it exists. That's not the way to do science. You have to seek the evidence. So when people say extraordinary claims require extraordinary evidence, and they are not seeking the evidence, it's actually a self-fulfilling prophecy. And given that he has so much money, I would expect him to put some money into looking out telescopes. That's the mistake of Enrico Fermi, that 70 years ago said, where is everybody? But what is the chance that aliens would visit Enrico Fermi when he was having lunch in Los Alamos, when time is measured in billions of years in cosmic history, and space is vast? The size of the observable universe is a quadrillion times bigger than the Earth-Sun separation. A quadrillion is 1 with 15 zero. Afterwards, it's 10 to the power 15. So, space is vast, and the chance that they would be exactly next to Enrico Fermi when he's having lunch in Los Alamos is really small. That's a sign of arrogance to say, I don't see anyone around me. It's just like being at home, looking around and saying, you know what? I have no partner. There is nobody that... we all know that to find a partner, you need at least to look through your windows and maybe use a telescope. That's the only way. So, it takes effort. And I say extraordinary evidence requires extraordinary funding.
Absolutely. And I can see why you're involved with Breakthrough Initiative and Pete Warden. It's like the similar idea of what Pete is trying to achieve with the Breakthrough Initiative.
Well, back in 2015, which was 8 years ago, almost 9 years ago, Pete came along with Yuri Milner to my office at Harvard. At the time, I was chair of the astronomy department for 9 years altogether. Yuri asked me to chair the advisory committee for the Starshot Initiative, which aims to visit the nearest star within a human lifetime. And I agreed. But a lot has happened in recent history because, we found the first objects from outside the solar system over the past decade. So in 2014, there was a meteor, an object roughly the size of a watermelon, that collided with Earth. And it burned up in the Earth's atmosphere as a result of the collision. Like a meteor, it created a fireball with a few percent of the Hiroshima atomic bomb energy. And that fireball was spotted by US government satellites. And they measured the speed of the object. And 5 years later, I found, together with my student Amir Siraj, this object in a catalog of NASA, and we calculated that it was moving so fast that in fact it was not bound to the sun. It came from outside the solar system. And it was moving outside the solar system faster than 95% of the stars near the sun. And moreover, it maintained its integrity down to the lower atmosphere, about 20 kilometers over the Pacific Ocean. And that implied that it has material strength tougher than all 272 other objects in the NASA catalog over the past decade. So if you see an object that is moving very fast and has high material strength, the first thought, at least that came to my mind, was that maybe it's a Voyager-like meteor. Imagine our own spacecraft leaving the solar system and colliding with a planet like the Earth. It would appear as a meteor of unusual material strength and unusual speed. And so we decided to go on an expedition to look for the materials from this object that landed on the ocean floor. And I assembled a team of 28 professionals, the best engineers and navigators in ocean expeditions, including scientists. And so we went there on June 14th to 28th in 2023. And altogether, we were able to collect with magnets, a set of magnets attached to a sled that we put on the ocean floor and went back and forth 26 times across a region of 7 miles in length, 1 mile deep. We retrieved 850 molten droplets, some of which that could have arrived from this meteor. And the location was identified by the Department of Defense and confirmed by the US Space Command as being associated with an object that came from outside the solar system. So I brought the materials back to the laboratory of my colleague at Harvard, Stein Jacobson, who is a world-renowned geochemist, and also used the laboratory of Dr. Roald Tagel at the Bruker Corporation in Berlin, Germany. And by now we completed the analysis of those materials. We found that a few percent, up to 12% of all these molten droplets are made of a composition of elements that is distinct from anything seen before or reported in the scientific literature. Some elements are up to 1,000 times more abundant than the initial composition of the solar system materials, include elements like beryllium, lanthanum, uranium, and others. And we called this composition BELAU, for beryllium, lanthanum, uranium. And we are now in the process of writing an extended paper about the findings. We already published 2 short notes about what we found. And it's very exciting because in addition to the object having a speed that made it from outside the solar system that implied that it's interstellar, we also identified an unusual composition of the materials that we found. And I even wrote a paper trying to explain this composition out of a natural process. But if it's not natural, it could be related to perhaps an artificial object. We don't know that. And so we are planning the next expedition now to collect bigger pieces that will inform us of the nature of the object.
Amazing. You must be waking up every morning curious about what's going to be found or what's around the corner. Avi, with that in mind, because I always ask my guests the 2 same questions. The first one is, I mean, we see space as a destination, right? It's a word. It implies a place to go. But I always try to go beyond that and try to attach the values or other words so that we can understand what these places represent. What would be for you 3 words that capture the essence of space?
Huge, and here I mean very large, both in terms of extent, physical extent, and the amount of time in its history. Time since the Big Bang. We don't know what happened before the Big Bang, but we know that everything in the universe, including space, the space that we see, is 13.8 billion years old. Okay, at the very least. So that's a very long time. I mean, the Earth existed only for a third of that. We just came along in the last third of the cosmic history. And of course, space is huge. Just within the Milky Way galaxy, you can find stars that are tens of thousands of light years away. It takes light tens of thousands of years to reach us from those stars. Okay, so it's both, and of course the universe we can see all the way to the beginning. So that means travel time of radiation that is 13.8 billion years. So both in terms of the extent of space and the amount of time that this space existed. So huge is my first word. The second word would be unexplored, because we haven't visited other places. And if we have a probe that we find sort of like a message in a bottle that arrives to us from another civilization, that it's just like learning about someone else in the ocean. Here the ocean is interstellar space, and I very much hope that this message in a bottle that we might find with the Galileo project that I'm leading would change our priorities, to go out to space, to be more curious about our cosmic neighborhood. So that is the second word, unexplored, and I very much hope that we will explore it. And the last word that I would use is educational, because my hope is that it will bring humanity to a better place. As of now, we are investing $2 trillion a year in military budgets worldwide. And I calculated that if we were to change our priorities, for example, as a result of receiving a message in a bottle, we would realize, that it makes no sense for us to engage in wars, in trying to kill other people, but instead we should allocate the same resources to exploration of space. I calculated that we can reach, or we can in principle send a probe towards every star in the Milky Way galaxy within a century with the same investment. And so that is the educational component, that instead of just fighting over limited territories on this rock that we were born on, we might realize that there is much more real estate out there. And it's just fascinating for us to explore it, and it will give us better perspective. It might give us, if we find a partner, it would give us a meaning to our existence. So altogether, it's educational.
Does that basically, so tying all these words, curiosity, education, collaboration, so what would be the human story of going to space beyond the science and the technology? What does it represent for us?
Most importantly is that we will find a smarter kid in our class that we can learn from. Okay, and there is this biblical story about Moses in the Old Testament looking at the burning bush, which was a miracle according to the Bible, and the burning bush was not consumed. Of course, today you can buy on Amazon a burning bush that would impress Moses as much and will not be consumed. It actually will not burn. It would just look as if it's burning. And so if I was next to Moses, I would have used the infrared cameras that we have in the Galileo project to advise Moses as to how much energy per unit time is emitted by this bush, and what's the surface temperature of it, and whether it was produced by a superhuman entity that Moses labeled as God. Okay? But this example illustrates the religious awe that we will be filled with if we were to encounter another civilization that is far more advanced than we are. And to me, a very advanced civilization is a good approximation to God. And it could bring, encountering it could bring religion and science together, because it will not be about a story, something that happened, thousands of years ago. It would be about something in reality that we can all witness. This is the reality that we all share. We don't need to put any goggles on our head. We don't need to take any drugs. It will be a reality that we can measure with our instruments, with our telescopes, and it would represent a technological civilization that is more advanced than we are. We would get a glimpse at our future technologies. And just think about a prehistoric cave dweller coming to a city like New York City today and looking at all the gadgets there. They would appear as miracles to that person. And the same is true for what we might encounter in 1,000 years if we were to visit that future. And so what we get from another civilization may be our future, but it's their past. And that is for a simple reason, that most stars formed billions of years before the sun. We know that. We can look at the universe, and it's sort of like an archaeological dig, because the farther we look, the more ancient is the light that arrives to us, because it must have been emitted earlier in order for it to make the distance. And so as we look deeper into the universe, we see images of how the universe looked like at earlier times. And we can measure how many stars are being formed at any cosmic history, any cosmic time. And most of the stars we know were made billions of years before the sun. And so that means that if you just imagine a similar clock operating around other stars, they could have had a civilization like ours, which existed billions of years before us. And it takes less than 1 billion years for the chemical rockets that we launch to move from one side of the Milky Way galaxy to the other. So they could have arrived to our neighborhood by now. And all we need to do is check whether there are such probes. I call it space archaeology, looking back and checking if others predated us, and what can we learn from them. That would be very instructive.
Do you think that when the internet came out, Mark Zuckerberg was really open about thinking that the internet or Facebook itself would just simply make the world a better place, and the platform ended up being, with pros and cons, bring people together, but also isolating people in their own silos. If we do find life, if we do find new civilization, do you think that we will be successful in connecting the dots and evolving and elevating the conversation, or some will actually use it to go, because it would force them to reassess thousands of years of stories that are hard to evolve from there? So what are your thoughts on that?
Well, I think it will be a test of our intelligence. In fact, this morning, after my morning jog, I jog every morning at sunrise, I posted a new essay on medium.com. So every day or two, I post something there. And the title of this one today, this morning, was "Let Us Focus on Being Intelligent." And what that means is not assuming that we are the most intelligent here on Earth and anywhere else, the way that we often prefer to believe, because it may well be that ChatGPT 5 will be more intelligent than us in terms of solving problems that the human brain is unable to solve, because GPT-5 has more connections than the number of synapses in the human brain. It will be a more complex machine than the human brain. It's possible that we will be given this sense of humility by our own creation. It's just like having, I have two girls and sometimes I don't understand them and they are better than me. And so it's just like having a biological kid. In this case, it's a technological kid that does better than us. And that may bring us some sense of humility. But I do think that we urgently need it also in the context of the search for extraterrestrial civilizations, because the gap may be far greater. It will not be incremental the way we see things on Earth. They may be far more advanced than we are, and it might require some effort on our side to interpret and understand what they're doing. And so, to me, it's an opportunity for us to grow, to learn, and it's quite possible that our own AI systems will be needed to understand extraterrestrial AI systems. It's sort of a twist on Alan Turing's idea of the imitation game, where he was thinking about computers or machines that we create imitating humans. And that's where the Turing test came along. The way I think of it is that ultimately our own AI systems will imitate extraterrestrial AI systems, and because they might feel kinship to those more than to us.
You make reference of nature often, and that's one of the things that I've always done, is look at the principles and the dynamics in nature so that we can understand our own journey, right? You look at nature, and nature doesn't want perfection. And it's tension, disruption, creation, and destruction.
Yeah, well, there are several differences between nature and human. Our society. Okay, one of them is that you don't need a legal system in nature because the laws of physics are obeyed. You cannot violate them. The laws of society, the legal system that we create, are violated every day because humans decide not to abide by the law. But you cannot decide not to abide by the laws of physics just by thinking that you will travel faster than light. That will not bring you faster than light. Okay? And so that is a big difference between nature and human activities, that nature, every atom in the universe follows the same equations of quantum mechanics. That's amazing if you think about it. And there are many more atoms than the number of people, actually. And if you ever find an atom that doesn't abide by the laws of quantum mechanics, you will get the Nobel Prize, because there shouldn't be any. It's amazing. The laws of nature, of physics, must be satisfied by everything. So that's one difference between humans and nature. And the other one is, that people very often have wishful thinking. And when they look at reality, they paint it in ways that are not realistic. And so if different people witness a car accident, they would give very different reports. So how do we avoid the fact that humans are not reliable detectors or scientific reporters? The way to avoid it is by using instruments. And that's not such a fancy concept that you might think came from academia, because actually FIFA, the soccer organization, they just used that principle in the women's soccer World Cup in summer 2023. When they had a dispute about whether there was a goal, they didn't go to the players or to the audience to ask their opinions. They used video cameras to figure out what happened. Using instruments is the way that science makes progress with. And so when we search for evidence, it's done using instruments, either telescopes, or in the case of the expedition that I described, it's a mass spectrometer or an X-ray fluorescence analyzer, in figuring out what our findings are. So, for example, some of my colleagues argued very forcefully that what we recovered in the Pacific Ocean is coal ash. Now, you may ask, why would they argue that? They didn't have access to the materials. Well, they argued that in order to lessen the significance of the finding. And that, that could be driven by psychological reasons, like jealousy, like the urge to step on any flower that rises above the grass level, all kinds of, or bullying, whatever, doesn't really matter. So what we did is very simple. We examined the material composition of these Belau spherules using a mass spectrometer and looked at 55 elements from the periodic table and demonstrated in a research note that was published last week that beyond any reasonable doubt, the element abundances of the Belau spherules are different than coal ash. And that's it. It settles the issue. It's not a matter of opinions. And so that's the beauty of studying nature and testing your ideas against the evidence. That's the way science is done, and I wish this approach was applied more broadly in society. But we all know that evidence is not always beneficial to some political views. And as a result, politicians don't rely on it quite often. And it works, and also in the courtroom, in the legal system, the jury pays attention to all kinds of psychological nuances sometimes. And we know of many examples of people who were convicted and the DNA evidence came later and they were exonerated. So unfortunately, in our daily life, very often evidence is not enough. Data is not enough.
Do you think it's I mean the fundamental nature of intelligence and entropy is the energy that it demands to investigate it, to create it, right? There's a conservation of energy in nature where, the least amount of energy between point A and point B, but then intelligence forces you to go outside the beaten path or or force and go in places where it demands an effort. It demands people to think. It demands people to, to spend an added energy maybe that is not necessary for survival things. And so I think that sometimes we underestimate these realities when we want to bring, for the science, is that this demands an effort, and we have to understand, we have to be humble. Ultimately, it always goes back to being humble and understanding where our strengths are and where we need some assistance. But sharing and making people understand that science is an effort of, an expenditure of energy would actually kind of make people a little bit humble. And how do we share and how do we create the structure so that people can be supported in that journey, right?
Yeah, I mean, it's a lot of work. And that was my criticism of what Elon Musk was saying. You can't just expect new knowledge to fall into your lap. The same is true about what Enrico Fermi said. You really need to work at it in order to unravel it. And the LIGO experiment, it took decades and almost $1 billion of investment before gravitational waves were detected. And it's a testimony to the human spirit that there were scientists that pushed it along. Ray Weiss, a colleague of mine from MIT, was telling me how difficult it was for him to convince his colleagues at MIT that this is worthwhile. And in fact, MIT didn't support him initially. And so sometimes these things, happen as a result of circumstances that, fortunate circumstances, like having an administrator at the National Science Foundation who found it exciting. And that's what happened in the case of LIGO, that eventually got the Nobel Prize. But altogether, I think, fundamentally, we have to ask ourselves, we live for such a short time, what would give meaning to our existence? Just being lonely is miserable. It's like saying that we are the smartest, but we are alone is really a very poor state of affairs. Like, why should we insist on that and not search? And if, gauging by our private lives, when you find a partner, it gives a new meaning to your existence. We all know that. And so we can apply the same to a partner in interstellar space, a cosmic partner. Because very often, when you are frustrated at home, realizing that there is a party that is going on in the neighborhood lifts your spirit. Now, it may take effort and time to go there. But if you can use a telescope to figure out that you have a neighbor, and in fact, the neighbor can educate you about your technological future and help you figure out things you haven't figured out yet, because our science and technology is only a century old. We discovered quantum mechanics just a century ago. And the fact that the two of us are speaking right now is based on our understanding of quantum mechanics. So just think 1,000 years into the future, how much better our life could be. And perhaps our neighbors already lived through that. In fact, many of them might have perished by now because their star was extinguished. The stars have a finite lifespan, and the sun has, only 7 billion years left out of its existence, and that's about 2/3 of it lived for 4.6 billion years, so it's almost 1.7 times the present age that is left for us, and eventually it will die, consume its nuclear fuel, and become a remnant, metallic sphere that is the size of the Earth, called the white dwarf, that will cool down. So imagine about the 2/3 of the mass of the sun, the core of the sun, cooling to become the size of the Earth. That's the future of the sun. And obviously, we will not be able to survive next to such an object at our current location. We will have to relocate. And gladly, most of the stars in the Milky Way galaxy would live much longer than the sun. But all good things come to an end. Nothing lasts forever in the universe, and therefore we should grow. We should move out. We should keep a legacy of what we developed here on Earth, but learn from our neighbors. That's the elementary thing that you might expect us to do instead of fighting each other on this rock.
Absolutely, totally agree. It reminds me of the book Into the Wild. He goes into the wilderness thinking he's going to find this communion with nature, and ultimately that leads him to his isolation and to his death. And this final line in the book is, "Life is nothing if not shared." Right? Ultimately, what brings value to our lives is what we find with others around us. Being alone leads to nothing. Avi, I
Right.
want to.
Yeah,
Go ahead.
I just wanted to bring up a metaphor. The North Sentinel Island near India, it has a group of people living on it, which are still hunters and gatherers. They have no contact with the outside culture that we currently have. And when there was a tsunami that was quite dangerous about 2 decades ago, and the Indian government sent a helicopter as a reconnaissance mission. The local tribes, the local people, shot arrows at the helicopter. They don't welcome anyone, and they killed actually a visitor that came there, a Christian missionary. And the question is, are we similar to that tribe? We basically do not care about what lies outside of our island, which is the Earth. And that would be very unfortunate because looking at this tribe, you realize how much they're missing.
Being mindful of your time, Abby, I want to shortly conclude with what would be your 3 words of wisdom that kind of wraps up your philosophy, your work, and your outlook on life?
Right. So most importantly is stay humble, modesty, maintain a beginner's mind, meaning that we should not pretend to be the adults in the room. I visited a couple of months ago the elementary school where I went as a kid, and I told the students there that I'm just like them, haven't changed much since I was their age. And one of them said, "How is that possible? You're 61 years old," because they read about me beforehand. And I said, well, it's not a matter of biological age. It's being open to learn new things and grow. So being a kid in the way you think and always willing to learn, I think that is extremely important. So being modest, having a beginner's mind. And the third thing is allow nature to surprise you, because nature sometimes has more imagination than our mind. And on a number of occasions, including quantum mechanics that I mentioned before, it's still a puzzle. It was a puzzle to Einstein. He just couldn't understand how it's possible to have reality not follow strict definitions of where a particle is at a given time and so forth, and causality the way he thought about it, and he was wrong. So quantum mechanics is still not fully understood, and that was completely a complete surprise that was forced upon us by experiments. And one of the experiments that showed Einstein wrong, that verified the quantum entanglement, received the Nobel Prize a couple of years ago. So I would argue this is an example, but there are many more probably that have to do with how to unify quantum mechanics and gravity. That would tell us what happened before the Big Bang, what happens inside a black hole. We just don't know that yet because we don't have a theory. And we keep thinking that we can come across the theoretical understanding, for example, in the context of string theory, just by pure thought. And my point is, without experiments to guide us, we will just not be able to imagine what nature is like. So allowing nature to educate us through evidence is key to gaining new knowledge, especially about space.
Absolutely. I mean, in Eastern philosophy, there is the belief that you can never become the master. There's always room to evolve, and the curiosity is at the root of it. Abby, you're going to be at TED in April. Is there something specific that you're going to be talking about on that
Well, I
time?
will describe my scientific work on the search for a partner in our cosmic neighborhood. And it is scientific in the sense that we use instruments and we already have some new results that I will describe. So I will talk about that quest, and I very much hope that in the coming years, I will find the answer to this question. Are we alone? I believe most likely not. And if not, where is the nearest bar that we can hang out with our neighbors, and I would like to ask them, what happened before the Big Bang? I want to know my cosmic roots. Maybe they have the answer.
Well, we'll be searching together. I'll be here in Vancouver, and Future Space is going to be hosting a second dinner, and we're looking forward to have you as one of our guests. And until then, Abby, keep going the amazing work, and I look forward for a time together.
Thank you so much. I look forward to seeing you there.
Have a good day.
Bye bye.